Alright, so I want to talk about a few economic concepts, starting off with revenue, cost, and profit. So generally we give these functions special names. The variables don't really matter, but we do use some special names here so that we don't have to have several functions called f or g, or something that is kind of hard to determine. So revenue we usually call r, or r of x, or r of something. But this is the money brought in for selling x items, and if you had to calculate it, you would say that the revenue is price times quantity, how many things you sell times what you charge. So this is just money you bring in. So for instance, you sell 100 boxes of donuts at $8 a piece. You can multiply that and see how much money you bring in. But in economics, there's also a cost. So we have a cost function, maybe C of x. And that's the cost of producing X items, or maybe just working with that. So when I get those donuts, I still have to pay somebody to make them, or if I made them myself, I had to buy ingredients. But usually when we talk about a cost function, we can think of a y equals mx plus b, or some other type of function. There might be a fixed cost like rental space or machines or something like that, or labor. And then we also have something that has a rate to it, a cost per unit times a quantity. So in some way we're almost making like a linear function there. And then if we have revenue, money we bring in, and cost, money we have to pay out, we can think about profit, and that's the money we get to keep after expenses. So profit is revenue minus cost, and it's possible to have a negative profit, means you have a loss. Okay, so think about those in real world terms. And let's try and make us some functions here. So the example we have here is Cedric pays $120 a day to lease a limo when he has a client. He also has to pay 25 cents per mile for driving. Now there's more to this, but all that describes a cost. Okay, he's having to pay $120 every day, and he also has to pay an additional 25 cents per mile. So if we're going to write a cost function, we could think about it as cost per mile, or cost per day. I don't know. Let's just call it C of x. Nothing wrong with that. I even say use x in the problem, so let's do that. C of x. So what does he have to do? He has to pay a rate of 25 cents per mile, and we're looking at miles as being x, plus he has to pay $120 per day. So C of x equals 0.25x plus 120. Now it says he charges his clients $3 a mile when they need his service. So $3 a mile he's charging, that's revenue, money he's bringing in. So that's a price times quantity. The price is $3. The quantity is X number of miles. So the revenue will be 3X. And the profit will be the revenue minus the cost. So that would be 3X minus the quantity of 0.25x plus 120. And we can clean that up. We can distribute that negative through the parentheses and combine some like terms, and what we'll have as a profit function will be 3x minus 0.25x, which will be 2.75x minus 120. So that's our profit. Okay, $2.75 times x minus $120. So the profit has to take away that cost of $120. Calculate revenue, cost, and profit values for driving 85 miles a day. So if I go in that order, revenue for 85 miles is 3 times 85. I got a calculator right here. I keep hitting the wrong button. I get 255. So if he drives 85 miles that day, his customers give him $255. But then he's got to pay the people he's getting the limo from. So we go to cost function, 0.25 times 85 plus 120. So let's see here. That's $141.25. So he may have people paying him $255, but he has to pay out $141.25. And then the profit, we can either use the function 275x minus 120, or we can take the revenue, which was 255 minus 141.25, and see what the difference is. So his profit on this situation is $113.75. Went too far. So there's a couple of questions. Well, one more question here. It says, determine the number of miles he must drive a client in a day to make money. So that would be either where we say the profit is 0, or where revenue equals cost. We'll just say where the profit equals 0. That's where he would break even. So we'll say 0 equals at 2.75x minus 120, and we'll solve that. So this will tell us how many miles he needs to drive to make money. So we'll solve that. We'll bring the 120 over. 120 equals 2.75x. We'll divide it out. 120 divided by 2.75. So that's approximately 44 miles. I'm rounding off here. So basically, if he goes through his day and he drives less than 44 miles, he loses money. If he drives more than 44 miles, he makes money. It might not be a lot, but that's the kind of his break-even point. So that's where we'll stop right there.